This task demands the construction of a function that will take in the number of units of electricity used and return the price, the bill total in pounds. So we're going to begin by defining a function, and let's give it the name calculate bill. The input into the function, the parameter that is going to be passed in, is going to be the number of units of electricity. Let's call this variable units. So the policy is that 38.2 pence is charged per unit for the first 120 units. So there are two possibilities here. The first one is that the number of units used falls within the range 0 to 120, and each one of those units is going to cost 38.2 pence. But there could potentially be units left over. So the two possibilities are, first of all, that the number of units is less than or equal to 120. And then secondly, the continuation, there might be the need to continue and add additional units at a different price. So let's begin by saying that if the number of units used is less than or equal to 120 units, then that means that we're going to take the number of units and we're going to say the price is equal to the number of units multiplied by 38.2 pence. Now, in that case, that means that the price will be exactly that. Now, otherwise, the price will decompose into two parts. We'll begin by saying that the price is equal to 120 times the base unit rate, and then we're going to say that the price becomes equal to the price before plus the additional amount that has to be charged on top. In order to work that out, we're going to take the number of units used, subtract 120, because we know that this number is more than 120 because we've entered the else block. And we're going to take that and multiply it by the other amount of money, which is 36.1 pence. This means that the construction of the price falls into two parts. We first of all charge 38.2 pence for the first 120 units, and then we add on the extra amount. Taking a step back and looking at this, what we can now do is we can cut this out of here and paste it down here instead of splitting it up into two lines of code. And this means that we charge the 38.2 pence for the first 120 units, and then the remaining units are charged at 36.1p. At this point, as we exit the if-else statement, we now know the price before VAT is added. Next, regardless of what the price is, we're going to have to add 5% for VAT. So if you think about it, to start off with 100% and add 5% brings us to 105% of the original price. So a quick way to do that would be to take the price and multiply it by 1.05, and that will have the effect of adding 5/100ths to the price, 5% to the price. Now that we've calculated the total bill, what we will know is we will know the price in pennies. However, in order to return the price in pounds, we will have to return the price divided by 100. We're going to use the normal divide sign, not the div operator and not the mod operator. That completes the function, and now we can test the function by adding some test code into the main body of the program. Let's begin by considering test cases where the number of units used is a perfectly valid value. This is a function because it returns a value as opposed to just finishing and returning to where it left off. So in this case, we can't call a function as a standalone line of code. We will have to do something with the result that we get back, and in this case, we're simply going to display it. So let's put in a test case that there were 45 units used. Let's take a copy of that. And let's put in 3 or 4 more test cases. Let's put in a boundary test case and say that there were exactly 120 units used. Let's put in a much larger number, now 165, and let's see what happens whenever there are 0 units used. This gives us a variety of test cases. Let's run the program, and now we can look at what the outputs are. So it says here that 45 units is going to give us 18.0495, etc., all the way down to a long continuous string of zeros with a 2 dangling at the end. More on that in a moment. Next we have that 120 units gives us 48.132. This is something we can very quickly check. So we can call up our calculator and we can say, let's take the price, which is 38.2 pence per unit. Let's multiply that by 120 units. And then let's multiply that by 1.05 to add the VAT, and we get our final result 4813.2, and that does marry up with our result here. 165 units gives us 65.18925, and finally 0 units gives us this. And quick checks with the calculator will confirm that all of those values are indeed the values that we were expecting. Now, thinking about the bigger picture of our program here, one of the things that we haven't kind of integrated into our function just yet is the idea of validating the number of units that has been input. So let's say, for instance, that there was some sort of a problem and the number of units entered was actually a negative number. We could begin with a quick check to say, if the number of units is below 0, then what we're going to do is we're going to print an error message, and we're going to say invalid units value, and then we can return some sort of a dummy value, maybe a 0, in order to make sure that the function returns a value from all pathways through the program. Next, I'm going to take another look at this part of the program here. We can see that in order to make this program readable and easy to understand and to follow our own thought processes as we arrived at this, we were able to say, well, let's begin by taking the original 120 units and multiply it by 38.2 pence, and then let's add the cost of the additional units which are charged at a slightly different rate. What we could do is we could manipulate this entire expression and simplify it somewhat so that instead of the computer having to run through all of those operations every time, it has a more simple job to do. So let's do that. What we can do first is we can use our calculator again. So let's call up the on-screen calculator to help us here. And we could say, let's take 120 and let's multiply it by 38.2 in order to give us the value of that. And it's 4,584. So instead of writing this part of the expression, we'll write 4,584. Then we will add, and this time we've got a set of brackets that we can expand. So it's the number of units take away 120, which can be expanded to say 4,584 plus, and then it's going to be 36.1 multiplied by the units value, take away 36.1 multiplied by 120. And again, by the use of the calculator, if we just clear the calculator, if we say 36.1 multiplied by 120, 0.1 multiplied by 120, we get our 4332, and we can therefore change that value to 4332, copying the whole thing out like this, take away a single literal value of 4332, and then if we take this original number and subtract this number, well, we can knock out the 4,000s to start with by hand, simplify our work somewhat, and we can take the 500 and the 300, and we can take away 300 from both of them, and that knocks that down to that. We can take the 80 and take away 30, and that brings it down to 50, and that knocks out that 30, and we can take the 4, take away 2, and it reduces it down to 0 in that case. And so we're left with a slightly more simplified version of this complex expression, which we could then take as a copy, and we can paste it back into our solution to give us a slightly more simplified, although much less readable, version of our program. So in this case, if we rerun the program, what we're expecting to see is that the results from this run of the program are identical to the previous run. And thanks to the fact that the shell still shows us the original results, we can rest assured that things seem to be working as they should. One final remark then about this program is that at the moment, when dealing with pounds and pence, we're sometimes seeing these very, very detailed decimal values, and this is to do with the loss of precision. When computers store real numbers, they struggle to represent them exactly as you and I would if we were writing our numbers down with base 10 and we were manually working through our working out. So this is a very unfortunate reality of working with computer programs with real numbers. Real numbers cannot exactly replicate the numbers that we had in mind, because all that a computer does is done in base 2, it's done in binary operations, and binary operations don't always marry up perfectly with denary numbers. So in this case, The program is currently not dealing with the fact that these amounts of money are being shown to effectively too many decimal places, and really what we need to do is tidy them up a bit and put them to 2 or maybe 3 decimal places as necessary. So that would be outside of the scope of this task, because the task is really just to write the function to calculate the price, but it's something that could be done as sort of an additional feature whenever you go to print out the results. And you might even want to go that little bit further and do something like put a pound sign on them to show that they are amounts of money. We can do that just quickly, copying and pasting. Next, we recognize that this is going to return a number, so that means that we're going to have to typecast it into string format in Python. Again, by the power of copy and paste, we should hurry through that, and then we can just type in a closing bracket to marry up with the str function there. Just quickly running that, it doesn't tidy up the numbers to 2 decimal places just yet, but it does give us the numbers in a more of a money format, apart from obviously the 0.0 there. And finally, we can use the round function in order to take the amount of money that we have and to put it to 2 decimal places. So we'll round each of these. So there's the opening bracket of round, and therefore we need the closing bracket of round to go here like this. So there will be those 3 additional symbols to introduce in here, and in here, thus leaving us with 2 decimal places at the end of each one. And there we have it. So it's given us all of our money values, apart from the 0 value, which is a strange anomaly, but that's okay. We can live with that. We could start introducing if statements and so on, but really it would be better to do that kind of thing in a separate function. And that completes the task. Really, that additional detail about 2 decimal places is really outside of the scope of what this task was asking for, which was the body of this function.